Hello and welcome to Lesson 6.5. Today we're going to look at what we call point-slope form. Now point-slope form is personally my favorite. Okay, I think it's the most useful when you're given either a slope and a point, or if you're given 2 points. Now by definition, point-slope form, okay, and this is for non-vertical lines. So the point-slope form of an equation for non-vertical lines that passes through a given point and has a slope can be found by going y minus y1 equals m times the quantity of x minus x1. So if you notice, our m value here is our slope. So m still equals our slope. And our x1, y1, this is the point that is given. So all you have to do is plug in what you know between your slope and that given point. And I'll show you how that works here in example 1. So example 1, part A, says write the equation of the line with a slope of -2, so that tells me m equals -2, that passes through the point, and this is x1, y1. And remember we said point slope form is y minus y1 equals m times a quantity of x minus x1. So now what we're going to do is we're going to plug in what we know. So I know that I have y minus y1, so I leave the y as it is, minus the y1 comes from my coordinate point, so this is a -3 equals m, which is my slope of -2, times x minus, and my x1 comes from this coordinate point as well, and that's going to be a +3. So take a quick second and look and make sure that you understand where we got all the pieces. Now, in order to write the equation of a linear line, I'm going to simplify. So I simplify, I have y minus a negative, so this becomes plus. So y plus 3 equals -2x minus 3. I'm going to go ahead and distribute. So this becomes -2x. -2 times a -3 becomes +6. And then I'm going to go ahead and get y by itself. So I'm going to subtract 3 from both sides. And my equation then is y equals a -2x plus 3. This is an equation of a linear line. This now is in slope-intercept form. Notice I didn't have to try to solve for the b. It just kind of worked its way out. So this is why I prefer the point-slope form. Let's look at how to do this one more time. So for part B, it says write an equation of the line with a slope of 2/5, and it passes through the point 10, -8. So again, I have x1, y1. This here is my m equals 2/5. So point slope form says that I have y minus my y1, which is -8, equals m, or my slope of 2/5, times x minus x1, which is 10. So I just plugged everything into the point slope formula. Now I'm going to go ahead and simplify. So y minus a negative becomes y plus 8. I'm going to distribute my 2/5 x, and the 2/5 onto a -10 is going to be a -4. And then what I'm going to do is I'm going to go ahead and solve. So I'm going to subtract 8 from both sides, and I'm left with y equals 2/5 x minus 12. And this right here, again, is in slope-intercept form, which we learned about in section 6.2. It's a linear equation, and it was way easier to plug into point-slope form and not have to worry about trying to solve for b. So another place where this point-slope form comes in handy is when we're given a graph, and we have points on this graph, and we have to write an equation in slope-intercept form. So again, because I have 2 points, I'm going to use point-slope form which is y minus y1 equals m times x minus x1. Okay, so the first thing I'm going to have to do here is I do not have the slope, so I'm going to solve for my slope. So this is x1, y1, I'm going to call this x2, y2. So my slope is 3 minus 4 divided by 2 minus a negative 1 becomes 2 plus 1, or I end up with a negative 1 divided by 2, or sorry, negative 1 divided by 3. Now my slope is a negative 1/3. I do anticipate a negative slope because my line is decreasing as I go from left to right. And now what I'm going to do is I'm going to pick 1 point, and it doesn't matter. I'm probably going to pick 2, 3 because they're both positive numbers, and I'm going to plug into this point slope formula. So I have y minus, I'm going to plug in my 3 for my y value, equals a negative 1/3 times a quantity of x minus 2. And now what I'm going to do is I'm going to go ahead and I'm going to simplify, and I'm going to do that. So here I have y minus 3. I'm going to distribute, so this is a negative 1/3 x. Negative 1/3 times a negative 2 gives me a positive 2/3. I'm going to add my 3 to both sides. So this is going to give me y equals a negative 1/3 x. Really, I have 2/3 plus 3. So my common denominator is going to be 3. So I have 2/3 plus 9/3, or I end up with 11/3. So I have y equals a negative 1/3 x plus 11/3. And again, I think that's way easier. Everything just works out so nice. I have an equation that is in slope-intercept form, just like as it was requested of me. I use point slope form to help me get there. Now the last thing we're going to look at is writing linear equations using data. In order to determine if we have a linear relationship, two sets of data have a linear relationship if the rate of change, and remember the rate of change is really a slope. So if the rate of change between two consecutive is key, pairs of data is the same. So let's go ahead and look at example 3 and see what we're talking about. So example 3 says, determine if the data is linear. If so, write an equation. So what I'm going to do is I'm going to use these 2 points as my first set, and I'm going to use my second 2 points as my second set. And again, we're looking to see if we have the same slope in between 2 sets of points. Okay, so I'm going to call this my x1, this my y1. Therefore, this will be x2, and this is y2. So I'm going to calculate my first slope, and I have 6 minus 4 divided by 3 minus a negative 1 becomes 3 plus 1. 6 minus 4 is 2. 3 plus 1 is 4. Or I get a slope of 1/2. So, and that is going to go right here. Likewise, for my next 2 points, because they have to be consecutive, okay, I've already got this one labeled x2, y2, so I'm going to call this one x1, y1. My slope for my next 2 points then are going to be 6 minus 7 divided by 3 minus 5. 6 minus 7 is a negative 1. 3 minus 5 is a negative 2. Negative 1 divided by negative 2 is a positive 1/2. So here, my 2 slopes are in fact the same. So we would say yes, these are linear. And because they are linear, we can now go ahead and write an equation. So I'm going to use point slope form, and I'm just going to pick a point. It truly doesn't matter. I'm going to pick the point 3, 6, just because I can. So I have y minus my y value, which is 6, equals m, which is my slope that we just found of 1/2, times x minus the x value that went with a 6 is 3. And now I'm just going to go ahead and simplify like what I have been doing all along. So I have y minus 6 equals 1/2 x minus 3/2. I have to add 6 to both sides. So I really end up with y equals 1/2 x. And I'm going to take my negative 3/2 and add 6 off to the side. So when I get my common denominator, that's going to be 2. So I'm going to make that 12/6. Negative 3 plus 12 is going to give me 9/2. So I really end up with y equals 1/2 x plus 9/2. And this would be my final equation. And for our last example, I'm again going to pick my first 2 points and then my second consecutive set. So it says determine if the data is linear. If so, write an equation. So for my first slope, I have x1, y1, x2, y2. So here I have negative 3 minus a negative 7 becomes negative 3 plus 7 divided by negative 1 minus 11, or negative 1 plus 11 is what it becomes. So negative 3 plus 7 is a positive 4. Negative 1 plus 10 or 11 is really a positive 10. So I end up with a slope of 2/5. Now I'm going to go do the same thing for the next 2 points, and I'm just going to call this x1 and this y1. So my slope for the next consecutive pairs is going to be negative 3 minus a negative 1 becomes negative 3 plus 1, and negative 1, because I got to go with my y2, so, or x2, so I have negative 1 minus 4. Negative 3 plus 1 is going to give me a negative 2. Negative 1 minus 4 is really a negative 5, or I end up with a positive 2/5. So I have the same slope. Now I just have to write it in point slope form. So y minus, a nice point here might be this point, like 4, negative 1. So y minus a negative 1 equals my slope, which was 2/5, times x minus my x value, which is 4. Now when I go ahead and distribute and simplify, I have y plus 1 equals 2/5 x minus 8/5. I have to subtract 1 from both sides. When I do that, I have to get a common denominator. So I end up with y equals 2/5 x, and I have negative 8/5 minus 1, which is really negative 8/5 minus 5/5, or negative 13/5. So my equation ends up being y equals 2/5 x minus 13/5. This is the equation of my linear line that passes through these coordinate points right here. So on that note, I hope you guys have a great day. Please let me know if you have any questions, and I'll see you in class.